Hello dear students, I welcome you all again on Wallah English YouTube channel. And guys, today we will discuss about the kinematic indeterminacy part. In the yesterday class, we have discussed about the static indeterminacy, basically internal static indeterminacy, how to calculate it for 2D structure. But guys, there is a very small portion which is still remaining. That is basically how to calculate the internal static indeterminacy for the 3D structure portion that we will discuss today in our class, guys. And in detailed discussion of 2D structure, for 2D structure internal static indeterminacy part, that we have already covered in the yesterday session, right? So guys, let us start this particular session. I hope you have understood all the concept which we have discussed in the previous classes. Okay, so let's start it. So guys, in our today's session, our major part is to cover the kinematic indeterminacy portion as well as the how to calculate the internal static indeterminacy for 3D structure. And the second thing, we will discuss the question also, guys, which is related to the kinematic as well as the static portion. Okay, okay sir. And as we have discussed, this portion we have completed yesterday. Okay, so this is my Telegram barcode, guys. You can scan it and you can get the link of my Telegram so that you can access it and you can join that particular group in which you are able to raise your query as well as you are able to get get this particular PDF as well as you will get the link of the classes also, guys, right? Okay, so let's start our topic. Which is basically the internal static indeterminacy. Internal static indeterminacy for 3D structure. So let's understand how to calculate the internal static indeterminacy for 3D structure. Let us discuss this and then we'll solve some problem which is related to this also. Okay. In yesterday class, we have already discussed how to calculate the internal static indeterminacy for 2D structure. The same type of approach or same type of concept you need to apply in case of 3D also, right? We have already discussed in detail how to find out the formula or how to get the formula for 2D structure part, right? So let's understand the internal static indeterminacy for 3D structure. So first structure which we are taking over here is rigid jointed structure. Okay sir. So guys, the first question is how many reaction you have in case of a 3D member as a internal reaction. That is our first question. So please write down in the chat box, guys, how many reaction you have in a 3D rigid jointed structure. If you have any kind of member in a 3D rigid jointed structure, how many reaction you may find? So basically there are 6 reaction. Okay, let us suppose this is a member. So in this particular member, guys, there are basically 6 internal reaction. 6 internal reaction are there. 6 internal reaction are there. And you know that, guys, what are they basically? We can write here like Fx, Fy and Fz. Similarly, Mx, My and Mz. Okay, that means in case of a 3D rigid jointed structure, there are basically 6 reaction in each and every member. So let us suppose if you have m number of members in the structure, then what will be the total number of internal reaction? That is equal to 6m. Okay, so let us consider m is total number of members, right? If m is total number of members, then can we calculate or can we find out what will be the total number of internal reaction? So total number of internal reaction, it is equal to how much, bacha? It is equal to 6m. Okay sir, 6m. Now guys, the question is, sir, in 3D structure or in 3D rigid jointed structure, we have joints also, and each and every joint will have joint equilibrium equation. So in case of 2D, we have 3 joint equilibrium equation, that is summation fx0, summation fy0 and summation mz0. But in case of 3D rigid jointed structure, we have 6 joint equilibrium equation, and that is basically summation fx0, summation fy0, summation fz0, mx0, my0 and mz0, right? So let us draw it and write it also. Okay, let us consider this is basically a 3D rigid joint. This is a 3D rigid joint. So at this particular joint, guys, we have 6 joint equilibrium equation. That means if you want to make this particular joint in equilibrium condition, then it should satisfy 6 joint equilibrium equation, and that is summation fx0, fy0, fz0, mx0, my0 and mz0. Simple, right? So let us write it down. Summation fx0, fy0 bacha and fz0. Similarly, guys, summation mx0, my0 and mz is equal to 0. If these joint equilibrium equation are satisfied at any rigid joint, then it is in equilibrium condition. Okay, sir. So there are basically 6 joint equilibrium equation at each and every joint. Let us consider there are basically j number of joints. J is basically total number of joint in 3D rigid jointed structure. Okay, if there are j number of joints are there. So guys, what is the total number of joint equilibrium equation? That is 6 into j, right? And you know that, guys, to find out the external static indeterminacy for 3D structure, we have already used 6 static equilibrium equation. So that's why in this particular case, the total number of available joint equilibrium equation should be equal to how much? It should be 6j minus 6, right? So let us write it down. So total number of joint equilibrium equation which are basically available, okay, it is equal to how much? Can I write here, guys? 6 into j minus 6. So our formula to calculate the value of DSI is very simple. What is the total number of reaction which is present as an internal reaction? It is 6m minus total number of joint equilibrium equation which is available. So we can write here 6j minus 6. So this is one of the formula, guys, which you can use to calculate the value of DSI. In yesterday class, we have discussed about the cut also, how minimum number of cut which is required to make a structure open, as well as we have discussed what is basically closed loop. So guys, while applying the closed loop formula in case of 3D structure, it will get fail. I will show you with one example so that you can understand why it is so. Okay. So guys, in case of 3D structure, you can use this one and the cut formula. What should be the minimum number of cut which is required to make a structure open? That particular formula you can use to calculate the value of DSI, right? Do not use the concept of closed loop in case of 3D structure because it is getting fail. I will show you with some examples so that you can understand why I'm saying that. Okay. So guys, let us write down the DSI can be written as in each and every member. We know that, guys, there are 6 internal reaction. So do you remember, guys, in our 2D structure we have written 3c dash. In this particular case it will become 6c dash minus r dash. What is r dash? I will explain, guys, in detail. What is r dash in case of 3D? I will discuss it. Similarly, if you subtract the reaction release from this particular formula, you will get the final formula to calculate the DSI. Okay. Okay, sir. Now guys, let us understand how to calculate the reaction release in case of a 3D structure. So let us suppose this is a 3D rigid joint, and let us consider this is the joint where we have some internal hinge which is present. So guys, if you want to calculate how many reaction are released, so you just need to write down 3 into m dash minus 1. This is the only formula which we have to use in case of 3D structure. Other than this condition, they are just not asking anything, right? So do not take any kind of tension, guys. Just use this formula to calculate the reaction release in case of 3D structure for rigid jointed structure mainly, where you will find some internal hinges. Okay. So guys, in this particular case, as you know that m dash is total number of members meeting at this joint, right? What is the total number of member which is meeting at this particular joint? So we can calculate it. It will depend upon you can see guys how many members we have, 1 2 3. So we can write 3 minus 1, that is equal to 2, 2 into 3, that is equal to 6. That means 6 reaction are getting released at this particular joint, like this, right? So let's solve some question so that you can understand both the formula, how to use it to calculate the internal static indeterminacy for 3D structure. Okay, let's do it guys quickly. Let's do it. Let us take one very simple example. First example, which is very simple, and in this particular example we will discuss both the formula as well as we will try to use the closed loop formula also. But guys, later on when we will solve another question, you will understand why I'm saying that do not use the closed loop concept in case of 3D structure. Let us consider all the supports are basically fixed support, and let us introduce one internal hinge also. Okay, we need to calculate the value of DSI for this particular structure. Okay, let us do it, a DSI as well as DSE also. Okay, so let us find out the value of RE, how much it is. Each and every support is having 6 external support reaction, so 6 multiplied by 4, that is equal to how much? 24. So we can write here 24. So let us write down DSE is equal to how much? It is RE minus 6. So 24 minus 6, that is equal to how much? It is equal to 18. That means total 18 external reactions are there which are redundant reaction. That means those reactions which are not, we are not able to find out by using static equilibrium equation alone, then such type of reaction is to be considered as a redundant reaction or known as redundant reaction. Okay, sir. So now you are able to understand what is the value of DSE for this particular structure. But let us understand how to find out the value of DSI also. We will use both the formula as well as we will use the third one also, which is closed loop concept. Okay, but later on I will explain it further. Okay, so guys, let us count how many members we have in this particular structure. There are 4 column and 4 beam, that means total members are 8. How many joint we have? 1 2 3 4 5 6 7 8. So 8 joints are there. Okay, sir. So let us calculate the value of DSI. It is 6m minus 6j minus 6 minus r dash. So we can write here 6m. How many members we have? 8 members, sir. Minus 6j. How many joints we have? 8. Minus 6 minus r dash. What is the value of reaction release at this particular location? Can I find it out? So 3 into how many members we have? 3 minus 1. So it is equal to how much? 6. Correct? So r dash is basically 6. So just calculate this. You will get your answer. What will be answer? How many members we have? 8. Okay. And 6 into 8. Yes. Minus 6 and then minus 6. Okay. Done. So how much it is? It is equal to 0. It is equal to 0. That means this particular structure is internally determinate structure. The structure is internally determinate structure. If we remove this particular internal hinge, then it will become internally indeterminate structure. But you can see here guys, if I add both the value, then ultimately the value of ds will become dse plus dsi, and it is equal to how much? It is 18 plus 0, so it is equal to 18 bacha. That means the total number of redundant reaction is basically 18. Clear? This is first example which we are discussing over here. Okay. Now guys, if I use the formula of number of cuts which is required to make this particular structure as a open, how many cut I need over here to make it open? Only single cut. Only single cut is required. So can I write it down guys? C dash should be equal to how much? 1. Then if it is 1, we can write here dsi is equal to 6c dash minus r dash. So how many cuts we need? 1, sir. What is the number of reaction reads over here? 6, sir. So 6 minus 6, it is equal to 0. Again, we are getting the same answer. We are getting the same answer over here. We are getting the same answer over here. Now guys, let us suppose if I want to find out the DSI value by using the closed loop concept, how we can do it? Just you need to count what is the total number of closed loop in this particular structure. You can count it very easily guys. Only single loop is there, right? So can I write here C is equal to what? C is equal to 1, sir. Again C is equal to 1, then we can write DSI is equal to 6C minus R dash. So it will become 6 into 1 minus 6, it is equal to 0. Sir, we are getting the same answer as we are getting by using the formula of member, by using the formula of cut. So why you are saying that this particular formula is not suitable in case of 3D structure, right? This particular question may arise in your mind guys, right? But don't worry about it. I will explain with one more example so that you can understand why I am saying that this formula do not use while calculating the value of DSI for 3D structure. Okay, understood? So let us write down. Let us write down. Let us write down. Let us write down. Let us write down the second thing, which is basically what? Second question. First we will write down the second question. Okay. Guys, after solving this particular problem, you will understand why I'm saying that. Okay, this is the structure which we have. Okay, sir. Now guys, first we will try to calculate the value of DSI by using the member formula. Then we will try to apply the closed loop as well as the cut concept, and I will explain how to apply the cut concept in such type of structure. I have developed some simple steps so that you can calculate or you can find out how many cuts are required to make this particular structure as a open, right? I will tell you about it. So guys, first of all, let us use the concept of members. How many members we have? Let us count it. 1, 2, okay, wait. We can see here guys, how many columns we have? 1, 2, 3, 4, 5, 6, 7, 8. Total 8 column. Then how many beam we have? On this level and on this level, it is 4 and 4. Again 8. So 8 beam, 8 column, that means total number of member is 16. Okay. Now the question is, how many joints we have? 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. That means 3 into 4, that is equal to 12. Okay, sir. So let us calculate the value of DSI. It is 6M minus 6J minus 6 minus R dash. In this particular case, how many member we have? 16. Minus 6 into J, that is 12. Minus 6 minus R dash is 0. So kindly calculate it. How much you are getting, guys? How much you are getting? Please write down 6 into 16 minus 6 into 12 minus 6. So how much we are getting? 30. 30. That means the value of DSI is equal to how much, sir? The value of DSI is equal to 30, sir. It is 30. This value is coming around 30. Okay. This value is basically 30, sir. Okay, sir. Now, guys, let us apply the formula of closed loop also. How many closed loop we have? If you count it, let's see. 1, 2, 3, 4, 5, and 6. So total number of closed loop is equal to how much? It is 6. If it is 6, then can I write here DSI is equal to 6C minus R dash. So 6 into 6 minus 0, it is equal to 36. That means the answer which we are getting by using the closed loop formula and the member formula are different basically. And if it is different, then there is something wrong. Kuch to gadbad hai, right? There is something wrong. So that's why I'm saying, you guys, please do not use such type of formula for 3D structure. Understood? Now listen, guys. Listen. How to apply the cut concept for this particular structure? Let me explain. So what you have to do, guys, you have to make a cut from the front. So how many cut required to cut these two member? 2, sir. 1 and 2. That's it. That means 2 cuts are required. Let us draw it. Let us draw it. So how many cut required? 2. First we will make 2 cuts over here. First we will make 2 cuts over here. One at this location and second one is at this location. Okay. So there are 2 cuts which is required to cut these 2 member first. Now what you need to do, guys, you need to take this particular structure like this and try to open it on a 2D surface or on a plane surface. Then what will happen? Let us draw it. Okay. Now guys, you can see here there are basically 2 cut which we have provided. You can see here there are only 2 cut which we have provided over here. Now this is our structure which is remaining. Okay, this is our structure which is remaining. Now tell me, guys, how many cuts are required to open this particular closed loop? 3 cuts. So 1, 2, 3. So total number of cut which is required to make this particular structure as a open is 5 basically. Not 6. It is 5, sir. 5. If it is 5, then can I write here, guys, C dash is equal to how much? C dash is equal to 5. If C dash is equal to 5, then the value of DSI is equal to how much? The value of DSI is equal to 6C dash minus R dash. That means 6 into 5 minus 0, that is equal to 30, sir. 30. That means we are getting the same answer as we are getting from the member concept, not from the closed loop. That's why I'm saying that, guys. That's why I'm saying that the value of DSI while calculating the concept of closed loop is what? Is wrong. My voice is not clear. Voice is low. Ashwin, voice is clear or not? Please write down. Now I think it is clear. Okay. So that's why, guys, you need to avoid this particular formula, which is basically the closed loop formula in case of a 3D structure. Understood? Do not use it. Do not use it. Do not use it. Now check, my audio is clear? Okay. Okay guys, so let's continue our session. Okay, so now you are able to understand why I'm saying that, guys, to avoid the formula which is basically the closed loop formula in case of a 3D structure. So try to use only the member concept and the cut concept to find out the value of DSI in case of a 3D structure, 3D rigid jointed structure. I hope it is crystal clear to all of you, and I think there is no doubt related to this particular part. Okay, so let's understand the next thing, which is basically our 3D pin jointed structure, again, which is a very, very simple concept. Let us understand it very quickly, guys, because we have discussed this complete formula derivation, this type of derivation in case of a 2D structure. That's why it is very easy to understand this one. So in each and every member, how many internal reaction are present? Only one internal reaction is present. What is the total number of member in a case of truss? Let us consider M. Total number of internal reaction, M into 1 only. At each 3D truss joint, how many joint equilibrium equation you have? 3. What are they basically? Let us write it down. Summation fx0, summation fy0, and summation fz is equal to 0. So these are basically our joint equilibrium equation. Joint equilibrium equation. Let us consider the total number of joint is J. Total number of joint is J. So can I write down the formula to calculate the DSI value? So total number of joint equilibrium equation is 3J. But the total number of available joint equilibrium equation is 3J minus 6. Why it is so? Because 6 equation we have used already to find out the external static indeterminacy, guys. That is the reason. So we can write here the value of DSI is equal to how much? M minus 3J minus 6. M minus 3J minus 6 to find out the value of DSI in case of 3D pin jointed structure. Okay, sir. So let us solve some problem first. Okay, just do this one. Just find out the value of DSE and DSI quickly, guys, for this particular structure, and let me know the answer, guys, quickly in the chat box. Do it, guys. Okay, guys. So tell me what will be the answer for this particular question as DSE and DSI. It is very, very simple. Let us understand this. Let us understand this. For this, it is 3. For this, 2 reaction. For this, it is 1 reaction. So can I write it down, guys? How many total number of external support reaction we have? That is basically 6. So can I write it down? DSE is equal to how much? RE minus 3. So 6 minus 3, it is equal to 3. What about DSI? We know that, guys, we can use the formula of closed loop or cut in case of 2D structure. So it is already open structure. So we can write here 3C dash minus R dash. So we can write 3 into 0 minus 0, it is equal to 0. So what is the value of DSE? It is 3. What is the value of DSI? It is 0, sir. That means B option is the correct answer. B is the correct answer for this particular problem. Okay, sir. Let us solve the next question and let us read it first. If the structure shown below is divided into two symmetrical parts as indicated, that means this structure is given to us and this is a section which is trying to divide it in two equal parts. This is first portion, this is second portion. Okay. Then what is the static indeterminacy of one of the portion of the structure? That means you need to calculate the static indeterminacy for one part, not the complete part. Okay. That means we need to find out the static indeterminacy for this particular portion or either this one. Okay. Let us do it. So you can see here, guys, how many reaction we have? 1 and 2. 1, 2 and 3. So can I write here, guys, the value of RE is equal to how much? It is 5. RE is equal to 5 for this particular part. We can write here DSE is equal to RE minus 3. That means 5 minus 3. 5 minus 3, right? 5 minus 3. So it is equal to how much? It is equal to 2. What about DSI? It is an open structure. We can write here 3C dash minus R dash. So 3 into how much? 3C dash. C dash is what? C dash is 0. R dash is 1 because one reaction is released. So that is minus 1. Minus 1 and 2, it is equal to how much? 1. DS is equal to 1. So you just need to find out the value of DS for one half of the structure, not the complete structure as per the given condition. So guys, we can write here C is the correct answer for this particular problem. C is the correct answer for this particular problem. Next question, you can do it by yourself, guys. I'm giving this particular problem as a homework. Just try it and get the answer. This one is also homework. Do it by yourself. Very simple questions are there. Okay. Now this is a truss. Let us understand what is deficit truss, what is perfect truss, what is redundant truss. It is very simple. It is very simple. Whenever the value of DS is less than 0, then in such case it is deficit truss. If the value of DS is equal to 0, then it is perfect truss. And if the value of DS is greater than 0, then it is redundant truss. So just we need to check it out. What is the value of DS for the given truss? What is the value of DS for the given truss? So can I write here, guys, DSE is equal to what? RE minus 3. What is the total number of reaction we have? 1, 2, 3. So we can write here 3 minus 3, that is equal to 0. What about the value of DSI, sir? We need to count the member first. So M minus 2J minus 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Total number of member are 13. Minus 2J. How many joints we have? 1, 2, 3, 4, 5, 6, 7, 8. So guys, if we solve it, 16 minus 3, 13, 13 minus 13, it is 0. So 0 plus 0, it is equal to 0, guys. That means this is the perfect truss. This is a perfect truss. So B is the correct answer for this particular question. I hope all of you are able to understand this thing, how to find out the value of DS for this particular truss. Guys, now this is the 3D truss question. And the 3D truss formula we have already discussed to find out the value of DSI. This we have already discussed. Now let us understand how to find out the value of DSI in case of a 3D truss. Okay, let's do it. So guys, there are two portions which is given to us. One is elevation part and second is plan. One is elevation and second is plan, which is given to us so that we can understand about this truss. Okay, sir. So guys, listen very carefully. We need to find out the value of DS. So DS can be written as DSE plus DSI. So what is the value of DSE? It is RE minus 3, sir. Not RE minus 3, sorry, RE minus 6, sir. So how many external support reaction we have for this particular structure? So guys, you can see here 1, 2, 3, 4, 5, 6. Total 6 supports are there, and each and every support is having 3 external support reaction. So can I write it down? 3 into 6, it is equal to 18. Minus 6. So how much it is? It is basically 12. So DSE is equal to how much? DSE is equal to 12. But what about, sir, DSI? DSI. M minus 2J minus 3. How we can count the member? By using this particular plan portion. You can see here how many member we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Total number of members are 9 basically. How many joint we have? 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Total number of member is, sorry, total number of joint are basically 9 again. So 2 into 9 minus this value is 6. Wait a minute. M minus 3J minus 6. Okay. M minus 3J minus 6. So 3 into 9 minus 6. So just solve this. You will get some value over here. So 9 minus 3 into 9 minus 6. So we are getting a value of minus 12. So if you add both the value, what you will observe, it is a determinate structure. That means 12 and minus 12. If you take the summation of it, you will get 0. That means this particular structure is determinate, internally determinate, as well as overall determinate structure. Overall determinate structure. Crystal clear to all of you or not? Please write down, guys, in the chat box quickly. Then we'll start our next part, which is basically the kinematic indeterminacy portion. Please write down any doubt if you have. Please write down in the chat box, guys, quickly. Any doubt, any doubt, any doubt? Please write down, bacha. Any doubt if you have, please write it down. Any doubt? Okay, done. No doubt, sir. So let's understand and let's start our new topic, which is basically the kinematic indeterminacy. Now in yesterday class, or we can say that in the first lecture, basically, not in yesterday class, in the first lecture, we have discussed about the indeterminacy part. What is indeterminacy for a structure? It is basically the total number of unknown which is present in a structure, that is known as indeterminacy. Okay. That is known as indeterminacy basically. But if we specify it, which is related to the reaction part, if we specify it as per the slope and deflection value, or you can say that the joint displacement values. So we have two type of indeterminacy. One is basically the static and the second one is kinematic indeterminacy portion. Now guys, the question is, sir, what do you mean by kinematic indeterminacy? So kinematic indeterminacy is nothing as it is the total number of independent unknown possible joint displacement. What is the total number of unknown independent possible joint displacement are there in a structure? If you are able to find it out, that means you are able to get the value of dk. If you are able to find it out, then you are able to get the value of dk. Okay, sir. So please remember this particular statement or definition. Otherwise, we are not able to calculate, or we are not able to develop the formula for dk. That's why it is my suggestion to please remember this particular statement. Total number of independent unknown possible joint displacement. Okay, sir. Okay, sir. Now, guys, we'll discuss one by one these type of words, what it is exactly. Possible joint displacement. Okay, so that you can understand the complete statement or complete formula also. Okay, so how we can represent the kinematic indeterminacy? It is represented as dk. It is represented as dk. So guys, first we'll start our discussion by taking 2D structure and especially 2D rigid jointed structure. How to find out the value of dk for 2D rigid jointed structure? Let us understand this particular thing first. Okay, sir. Now guys, listen very carefully. Let us suppose this is our structure. Listen very carefully, guys. Then only you can understand whatever I am saying over here. Let us consider this is a single bay portal frame which we have, and let us suppose in this particular structure we have j number of joint. But before that, let us understand one thing. Each and every rigid joint in this particular structure can have 3 joint displacement, which is basically delta x, delta y and theta z, which can be possible at each and every joint. So can I write it down, guys? Can I write it down? If I take a rigid joint, if I take a 2D rigid joint, then at this particular joint there are basically 3 joint displacement which can be possible, and that is basically delta x, delta y and theta z, which can be possible at this particular joint, right? So can I write here, guys, at each joint 3 joint displacement are present. 3 joint displacement are present, which is nothing as delta x, delta y and theta z. Okay, sir. Let us consider the total number of joint is j basically. Total number of joints is basically j. So can I write it down, guys? Total number of joint displacement, total number of joint displacement is 3j. But are all these type of displacement in this particular structure are possible? No. Why? Let me show you with some drawing. Okay, what we have written, at each and every joint we have 3 joint displacement. Let us write it down. 1, 2 and 3. We'll write like this: delta 1, delta 2 and theta 3. Then 4, 5 and 6. Then similarly we have 7, 8 and 9. At this joint also 10, 11 and 12. Okay, but tell me, guys, whenever you find any support reaction, then that support reaction will try to stop that particular displacement which is in the direction of reaction itself, right? So you know that, guys, if this particular support is having 3 external support reaction, then due to this external reaction these 3 joint displacement will become 0. It is 0. It is 0. And this one is also 0. That means the value of joint displacement at this particular support is known to us. Okay, sir. Similarly, at this support, we have all the values as a 0, right? That means delta 11, delta 10, delta theta 12 is 0 basically. Why? Because of external support reaction. That is the reason. So guys, how many joint displacement are remaining in this particular structure? It is 6, sir. It is 6, sir. Can I say that then? Then can I say that, guys? If you have Re as a total number of external support reaction, then if you subtract that particular value from this particular value, then you will get the total number of unknown possible joint displacement. Correct? So can I write it down, guys, over here? Total number of, or we can write like this, because that particular value is nothing as dk. We will write like this: 3j minus Re. 3j minus Re. Why we have subtracted Re from this? Because we know that the reaction or the external support reaction will stop or make joint displacement as a 0. That's why we need to subtract the value of Re from 3j. Understood? Okay, sir. So this is one of the step or one of the formula in which we have considered all the type of joint displacement which can be possible in the structure, right? So now you are able to understand what you mean by, sir, possible. If external support reaction is there, then that particular displacement is not possible. If external support reaction is not there, then that particular joint displacement is possible. Clear? So now you are able to understand what you mean by, sir, possible joint displacement. If reaction is there, not possible. Reaction is not there, possible. Simple. Okay. As well as what do you mean by unknown? Unknown means whose value is not known to us. In case of external support reaction, you know that, guys, there are certain displacement whose value is known to us, and that is basically 0, right? So now you are able to understand this also. What do you mean by unknown, sir? If it is unknown, then the value is unknown for us. If the value is known, that means it is 0 or something else. Okay. So these two statements or these two words you are able to understand. Now the question is, what is basically independent? That we will discuss. Okay. That we will discuss. But we need to take some more example first. Now this is a very simple case which we have discussed as a first case. This is a very simple case which we have discussed as a first case. In second condition, guys, what happened? In second condition, let us suppose, there are some members, which are axially rigid or inextensible. What it means, sir? Let us understand this first, then we'll write down the formula. Let us suppose there are some members which are axially inextensible or axially rigid. That means, let us consider this is a member, and if I apply the force, then this particular member is not trying to deform in the horizontal direction. That means it is axially rigid. In axial direction, it have the stiffness which is infinite, and due to infinity stiffness, that's why axial stiffness basically it is infinite, and if it is infinite, that means it will not try to deform in the axial direction or in the horizontal direction, basically like this. So that's why such type of displacement value is not possible, or such type of displacement value is 0. So if it is 0 or it is not possible, then you need to remove it from dk. You need to remove it from dk. So let us consider there are nr. Let us consider nr is total number of members which are axially rigid. If it is axially rigid, so what we have to write, we have to remove this particular value from our dk. So initially our dk value is 3j minus re. Now you need to subtract nr also. You need to subtract nr also, so that the number of members which are axially rigid or they are not deforming in the axial direction, you need to remove that particular displacement value from our dk. Clear? Clear, sir? So let's take one example so that you can understand it. Let us consider this is our structure in which all the members are axially rigid. In this particular case, all the members are axially rigid. Axially rigid. Members are axially rigid basically. If it is axially rigid, then what is the value of nr? We can write here, guys, nr is equal to 3. 1, 2, 3. nr is equal to how much? It is equal to 3. Okay, sir. So can I write down the formula basically? dk is equal to what, sir? dk is equal to 3j minus re minus nr. Okay, sir. So guys, how many joints we have? 1, 2, 3, 4. How many external support reaction? 3 and 3. That is equal to 6. But what about nr value? In this particular case, what is the value of nr? nr is equal to 3 in this case, sir. Right? So let us write it down. 3. So guys, if you calculate it, so what you will get exactly? Again, the answer is 3. That means 12 minus 9, that is equal to 3. So what are the joint displacement which we have to show over here, which is basically considered as a dk. So you can see here, guys, this theta can be possible. So theta 1. This theta can be possible, theta 2. But what about the third one, sir? So guys, in this particular case, the third one is basically the sway. Delta 3 is basically our sway in this particular case, which is nothing as our third joint displacement for this particular structure. Now the question is there, sir, in this particular structure you have considered sway displacement as an unknown displacement, but in the previous question you didn't write anything regarding the sway value. Why? So let me explain it. So guys, when the members are not axially inextensible, right, or axially rigid, then in such condition this delta 1 and delta 4 is possible. Okay, sir. Delta 1 and delta 4 is possible. If it is possible, then we are able to find out the value of sway in this particular case directly by calculating delta 1 and delta 4. That means in this particular condition, sway is also there, but that particular sway is dependent value. This one is dependent value. Why it is dependent? Because if you allow delta 1 and delta 4, so whatever net value will be there, by adding it or by taking the algebraic sum of it, you will get the value of sway. That means in such condition, the delta or the sway value is dependent, but in the second condition, it is independent. In this particular case, it is independent. It is independent. That's why you need to consider it in this particular case. I hope you are able to understand this. I hope you are able to understand this very well. Clear or not? Clear or not? Please write down, guys. Okay. Let us take the third condition. Let us take the third condition. Let us take the third condition. And third condition is nothing as basically in which there are some hybrid joint. Hybrid joint, or you can say that some reaction are release. Some reaction are release. There are some hybrid joint or some reaction are release. Listen carefully, guys. Listen carefully. If there are some hybrid joint or some reaction are released, then what will happen? Let us suppose this is our rigid joint initially. So at this particular rigid joint, we know that there are three joint displacement, which is delta 1, delta 2 and theta 3. Okay, sir. Now let us suppose, guys, if I put an internal hinge at this particular joint, then what will happen? If I put an internal hinge at this particular joint, then what will happen, sir? So guys, in this particular condition, this member and this member can move independently. Let me show you so that you can understand it. In this particular case, this member can make an angle theta independently. It is not depending upon the other member, right? It can move any value of theta, right? That is the reason. Second thing, this member can also have independent value of theta, right? That means theta 2. So guys, both the value of theta are different in this particular case, and they are not depending on each other. That is the reason due to which we need to consider theta 1 and this is theta 2. And 2 linear displacement are already present, 3 and this is 4. So total degree of freedom of this particular joint is 4. But in the previous case, it is 3. Why it is so? Let me show you that. So guys, in the previous case, this particular joint is ridge joint. Ridge joint means the angle between the member will remain same before and after loading condition. In such case, you know that if this particular member is moving by theta, then this member will also have to move by theta. Otherwise, the condition of ridge joint will not get satisfied, right? So that's why guys, in such condition, if this is independent, then this is dependent, or if it is independent, then this is dependent. Clear? Okay, sir. So can I say that guys, due to reaction release value, the value of decay is getting increased because you are having some extra unknown joint displacement which can occur in the structure due to some hybrid joint or due to some reaction release value. Okay. So can I write here guys, the value of decay is nothing as, it is basically 3j minus re minus nr plus r dash. Now the formula is having some additional value which is basically the r dash value. I hope you are able to understand this. Please write down in the chat box guys, yes or no. Please let me know it quickly. Crystal clear or not? Okay. So let us solve some question first. Okay. Let us solve this particular question. What they are asking basically, this is the gate problem which was asked in your gate examination guys. So what they have given, consider the frame shown in the figure. If the axial and shear deformation is different in, if the axial and shear deformation in different members of the frame are assumed to be negligible, the reduction in the degree of kinematic indeterminacy would be equal to. So that means, let us suppose guys, in the initial condition you have some value of decay, but after considering the member is not having axial and shear deformation, that means the member is axially rigid. If it is so, then what will happen? You need to find out what should be the reduction in the value of decay, right? So it is very simple. Let us consider first condition when the member are not axially rigid. So our formula is 3j minus re minus nr plus r dash. When member are not axially rigid, then 3 into j, 1, 2, 3 and 3, 6. Re is equal to how much? 4. Nr is 0, reaction release is 0. So what is the value? 12 minus 4, that is equal to 8. Okay, sir. When members are axially extensible. Okay. Now let us suppose guys, if member is axially inextensible, then in such condition, what is the value of nr? 1, 2, 3, 4, 5, 6. So nr is equal to 6. Okay, sir. If nr is 6, then dk is equal to how much? 3j. J is 6. Reaction is 4. Nr is 6 plus r dash is 0. So if you calculate it, you will get 2. So tell me guys, what is the value of reduction, means how much value of decay is getting reduced. So initially it was 8, now it is 2. The reduction is basically 8 minus 2, that is equal to how much? 6. So answer is B. B is the correct answer for this particular question. I hope you are able to understand it very well guys. Yes or no, please write it down. B is the correct answer. Now let us solve this particular question. This is GATE 2004 problem. You need to find out the value of decay. You need to find out the value of ds. Okay. And in this particular case, they have written it, axial deformation is negligible. Okay. You have to ignore the axial deformation. Okay guys. Now I will tell you another way to calculate the decay for this particular structure. Listen very carefully. So guys, we will not use the formula in this case. We'll try to draw it on the structure itself. Okay. So we know that guys, this particular joint can rotate theta 1. This joint can rotate theta 2. This joint can rotate theta 3. This particular end is a free end. It can also rotate theta 4. And this can also move in the vertical direction 5. Then 6. Then 7. Then 8. Then at this particular support, we have 9. 10, and it can move in linear direction or horizontal direction also, 11. Then one of the sway component 12, and at this level we have sway which is different. Both the value will be different and both are independent. So total value of decay is 13. Decay is 13 guys. Decay is 13. What about ds sir? So dSE is equal to RE minus 3. So RE is how much? 3 reaction and 3 reaction. So total 6. 6 minus 3 is equal to 3. What about DSI? DSI is equal to how much? 3C dash minus R dash. So how many closed loop we have? 2. So 3 into 2 minus 0, it is equal to 6. So 6 plus 3, that is equal to 9. So 9 is DS value and DK is how much? 13. So that's why D is the correct answer for this particular question. I hope all of you are able to understand how to calculate the value of ds and how to calculate the value of dk for this particular structure. This question we have already discussed guys. It is asked in the GATE 2008. If the axial deformation is neglected, then what is the value of decay for single bay portal frame? We have discussed it already. This is single bay portal frame. And if axial deformation is negligible, then this is theta 1, theta 2 and delta 3. So answer is 3. Already discussed, right? Now guys, this is an interesting question. We will discuss it later on. Okay. Now let us understand the remaining formulas. Okay. Now up to this, I hope you are able to understand how to calculate the value of decay for 2D rigid jointed structure. Okay. Now let us understand what is the value of decay for 2D truss. So guys, for 2D truss, the formula is very simple. Let us consider, in this particular case, we don't have to consider any reaction release. We don't have to consider any kind of axially rigid member like this. Okay. The formula in case of a truss is very, very simple, right? Now in case of a truss, each and every joint is having 2 joint displacement. And what are they basically? Delta 1, or you can say that delta x and delta y. Only linear displacement is possible in case of a truss, right? So if J is the total number of joint, then what will be our formula? 2J. And if external support reaction is RE, so we can write here 2J minus RE. And this will be our formula to calculate the value of decay in case of a truss. Very simple. Very, very simple guys. Very, very simple. Right? 2J minus RE. So let us do this particular problem. How many joints we have? 1, 2, 3. So let us calculate the value of decay. 2 into 3 minus RE. RE is 3. So it is equal to 3. That means 3 joint displacement can be possible for this particular structure. Right? And let us show it also. Let us show it also. So we can write here, this one is delta 1, this one is delta 2, and this is delta 3. That's it, right? That's it. Now guys, if I want to write down the formula for 3D structure, again it is very simple. Let us write down, because we have already discussed in detail how to develop the formula. That is the reason. Okay, so for 3D rigid jointed structure, can I write it down? In case of 2D rigid jointed structure, it is 3J. In this case, it should be 6J. Minus RE minus NR plus R dash. Simple. 6 is nothing as basically 6 joint displacement can be possible. Delta X, delta Y and delta Z. Theta X, theta Y and theta Z. Clear? So this is our formula for 3D rigid jointed structure. Simple, and I hope you are able to understand this. Okay, and the remaining term, which is NR and R dash, it will remain same guys as we have discussed in case of 2D, right? But you know that in case of 3D we have one condition, which is basically the reaction release. So in this case, reaction release formula is 3 into m dash minus 1. Simple. Next thing is basically 3D truss. For 3D truss, you can write down the formula dk is equal to, in case of 2D truss, we have two joint displacement, delta x and delta y. In case of 3D truss, we have delta x, delta y and delta z, right? So we will write the formula 3j minus re. So in this case, it is delta x, delta y and delta z. So this is our formula to calculate the value of dk in case of 3D truss. If you understand one formula in detail, then other formula are very simple. Just you need to write it down on the board, nothing else, or on your copy. Simple. Because you know that guys, what it means actually. Crystal clear or not? Please write down guys in the chat box. Okay. Any doubt, any query if you have, please write down guys. Any doubt, any query if you have, please write down. Crystal clear? Okay. So let us solve this particular question, and tomorrow we will bring some more question guys. The remaining question we will discuss tomorrow. Okay, this is the question which we will discuss today in this particular class, and the rest of the question we will discuss in the tomorrow session, and we will bring some different question also guys in our tomorrow lecture. That means tomorrow lecture is completely practice session. Okay. So a properly constrained rigid system has several degree of freedom. If it is properly constrained, that means it will have 0 degree of freedom. That means the first statement is itself wrong. If a system is properly constrained, how it can have some degree of freedom? It is 0 basically, right? The number of degree of freedom of a locomotive moving on a railway track is only 2. No, it is 1. Why? Because you know that guys, the train engine can move in the one direction only, right? It is moving in the single direction. Why train is trying to turn? Because of track is turning, right? So guys, please remember this particular point. The locomotive which is moving on a railway track is having only single degree of freedom. It can move in the horizontal direction. That's it. Okay. If railway track is turning, then only locomotive is trying to turn it. So that's why this statement is wrong. A floating ship is having 6 degree of freedom. Yes, it is so. You can understand by this particular example. Let us suppose this is a ship which is moving in this direction, 1 degree of freedom. This direction, 2 degree of freedom. When the wave is coming, so it is moving like this also, right? So 3 direction, that means vertical direction also. Now guys, let us suppose this is our axis and the ship is trying to move in the horizontal like this. So it may have some angle with respect to this particular horizontal line, theta 1. Let us suppose this is vertical. It can move like this also. It can move like this also. 1, 2. Understood? Yes or no? Let me show you that here. Very simple to understand. Let us suppose ship is moving in this direction. So we can write it delta 1 it can move in this direction also, delta 2. It can move in this direction also, delta 3. And why it is so, I have already explained it, right? Now guys, if ship is trying to having some movement or having some rotation about this particular axis, which is this one, right? So we can write here, it is theta 4. Now ship can have like this also. This is our ship, right? And it is trying to getting some rotation about this particular axis also, like this, right? So guys, this is theta 5 and this one is theta 6. If it is vertical axis, your ship can rotate about it like this. So total 6 degree of freedom for a floating ship. That means this statement is correct, and that's why B is the correct answer for this particular problem. Okay, now the remaining question guys we will discuss in the tomorrow class, right? And please try to cover it, the complete session, as well as try to understand each and every formula. If you find any difficulty in understanding the formulas or the concept, please let me know. I will help you once again guys, there is no problem. You can ask me anything, right? You can join my Telegram also guys, which is basically Krishna Yadav. Let me write it down, Krishna Yadav Sir PW. You can join this particular Telegram guys, so that you can post your any kind of doubt, any kind of query, or if you need any kind of suggestion, you can ask me anything, right? Second thing guys, you will get the PDF also, as well as the class link of our series on this particular Telegram. So kindly join it if you want. Okay, so this is all about for today guys, which we have discussed. So thank you so much for joining the session, and guys I hope you are enjoying this particular series, you are enjoying this particular session also, those students who are watching this particular video as a recorded. So guys, kindly complete all the session one by one, so that you can understand each and every topic. Again, if you find any difficulty, please let me know, I will help you guys. Okay, so this is all about for today guys. So thank you so much. Let's meet tomorrow at the same time, in which we will discuss the further thing. Okay guys, bye bye and take care. Thank you so much.